Good afternoon, folks. This is Satish Iyer, here to discuss about HPC storage, how to unlock the value of your data with HPC storage solutions from Dell. So those who have seen Dell's HPC storage presentation probably remember this. Our vision is to have an intelligently manage the data throughout its life cycle. As HPC experts, you know that you have a lot of data and lots of different use cases, and one solution does not fit all. Hence, you need these solutions to coexist, starting from fast crash to project space all the way to archive and deep storage. So Dell's vision is to provide you one, if not many, solutions for that, various ranges of requirements from a customer's use case perspective. And we typically, you can think of this as two different kind of releases from our side. One we call as validated designs for HPC storage, and I'll explain what those are. And then you have the storage portfolio from PowerScale and Elastic Cloud Storage, or ECS, that is also a great addition to any HPC use case. So let me walk you through the validated designs first. So a validated design generally is a well-defined reference architecture that is very well optimized, provides you building blocks that you can consume quickly, deploy quickly, and make it production ready. It simplifies the complexity of HPC storage requirements. It increases the uptime by reducing the guesswork you yourself or your engineers need to do to, say, develop, architect, design, and optimize it. And essentially, it saves your resources. So you can consume it quickly, you can get it up to a production level and get it up and running. It scales, it provides you capacity, it provides you performance, etc. So it's a very well-defined solution that we have been doing for many years, and they have different nomenclature we used to call as ready solutions in the past. So it's an improved taxonomy that's validated designs is all about. Essentially, there are two to three validated designs I'm going to cover. Most of them are on the parallel file system space. Essentially, any customer who would like to have a scratch space that requires parallel read and write and have a ultra low latency requirement, these solutions fit pretty well in that space. So starting with, I want to start with the Pixor storage. The architecture slide you see is pretty busy. The way to read this is look at anything that's in the dotted box is an option that you can have. That shows that there are plenty of ways you can configure this, and that's the value we bring to the table. We manage the entire architecture for its life cycle. That means we manage the infrastructure that goes underneath, or a CPU, or any of the components that have a major release. We go back and re-architect it, optimize it, make sure that everything works, all the components works, and we provide you full detailed benchmarking to the point how exactly we did those benchmarking, including those commands. We provide you all of this information up front. So let me demystify this pretty busy slide here. Start looking at this block underneath here where I'm showing it the arrow with the mouse arrow here. There are two ways you can consume this. One is called a standard architecture. Another one is called high metadata architecture. A standard architecture will have two servers. This is getting refreshed to the latest 15 generation servers of R750 powered servers. And two of the servers can be connected up to 4 PowerVault ME4084 storage enclosure. Each of the ME4084 enclosure can support up to 84 drives or spinning drives of various capacities. We always want to request that this fully populated do not start with a partially populated enclosure. So we provide those 2 servers plus the 4 ME PowerVault ME4084 essentially makes it the first building block. And along with the management server of R650, you can deploy Pixor storage. PickStore storage is essentially a Spectrum shell with a PickStore software on top of it from our partner ArcStream. We've been doing this for many years. It makes the a Spectrum scale deployment pretty easy with the PickStore architecture. It provides you an ability to start from a parallel file system and connect other POSIX file systems all the way to the cloud. So this is pretty compelling solution from our side. If you have a high metadata requirement, you can add additional metadata servers and storages where you can use either SSDs or NVMe for metadata. It gives you high performance. If you simply want additional capacity, you can add JBoss to the PowerVault ME4084 to get additional capacity. If you're looking for super high IOPS or throughput, you can add NVMe-based servers, R650 in this case, to this to provide you NVMe-based block storages. You can add additional gateway nodes. So it's a lot of different ways to do this. So please talk to us, your requirements, and we can optimize the right architecture for you that'll optimize your licensing underneath as well. The way we deploy and deliver this is just like an appliance. It's not, we have all these various options, so it's not truly an appliance as a black box, but we provide you everything from rack stack of the hardware, software load, all the way to integrating that to your data center so that we come and do the last mile integration work so you can get into production really fast. So it's a pretty compelling solution that we are working with our partner ArcStream in our engineering and deployment and support. Fully supported for both hardware and software. We also provide the capacity-based licensing based on spindle count, not based on the capacity itself. Another cool option we have with this solution is called a software called Ingenia that helps you to connect to various other POSIX file systems. It'll help you to replicate the data. It'll provide you an ability to connect to the cloud as well. So as you can see, there are lots of ways you can configure this, and it's a pretty exciting architecture from our side. The next validated design I want to talk to you about is about BGFS. So you're all familiar BGFS as a parallel file system from ThinkPark in Germany. We have two architectures that we typically talk about for BGFS. One is a high performance storage solution, which utilizes a two-socket server, powered server R750, with NVMe drives in it. It can come up to, it can be provisioned in two ways, a 16-node version and a 24-drive version. We, again, always recommend that you fully populate the servers. Do not start partially populating and add drives later. As BGFS is a software-defined architecture, you can start it in any which way, but our optimization, our efforts say that a small configuration of 3 servers of R750 plus 1 management node is an optimal way to start it. In that, you can see that this golden color of half of the drives in one server is allocated towards metadata to avoid NUMA issues. And then you can keep adding one server at a time as you want to grow. So this is a super fast, pure scratch solution. Some of you may get a heartburn seeing that it's a RAID 0 configuration. That's how I benchmark to show the maximum performance that you get. You can see the numbers out there for a 16 drive. For a 3 server configuration, your peak read write is around 116 and 62 gig throughput. So it's like it's like pretty fast, and it also gives you almost like 2 million IOPS in that configuration. Really fast solution, and you can configure it with the RAID 10 option, or you can use buddy mirroring from BGFS, or you can use other third-party software that'll give you server level redundancy as well. So we have the way we support it is we provide the support for the hardware, and we also have collaborative support with ThinkPark for the software as well, whether it is 5x9 or 7x24. The other architecture I want to show you is a traditional parallel file system, what we call as high capacity, primarily using spinning drives for capacity and scale. So this is a very simple traditional parallel file system architecture. You have a management node of R650. You have 2 R750s providing a metadata server connected to a PowerVault ME4024 with SSDs for metadata, and you can have two other servers connected to the four PowerVault ME4084, very similar to the Pixstore storage for capacity. You can scale it as a building block. You can consume it in small, medium, large. One ME is a small, two ME 4084 is medium, and four ME 4084 is a large. So you can have the flexibility of start small and scale up. When you want to scale more than this, what you see in this picture, you just add another couple of servers and add the storage nodes and scale. We have pretty good throughput and IOPS on this as well as all our parallel file systems, making it a well optimized, highly available architecture that you can deploy your parallel file systems needs. The next one I want to talk to you about is a quick solution. We call it Solution Inside because it's a reference architecture. We've been doing this for over a decade now for any NFS stores. I know all HPC customers know how to build them, but we want to show you that we have optimized it. Any capacity up to 1 petabyte raw. It is the right architecture. You get very well fine-tuned, highly available architecture with good throughput and performance attached to it. All we use is two R750s as the servers and connecting an PowerVault ME4084 as a data store. As you can see, this we've been doing for many, many years. That means every time the server or storage changes, we're going to have a refresh on it so that everything works and all the connections work. The InfiniBand MOFET and every other software that goes with it is also optimized for your needs. So this is a section about our validated designs. And now I want to jump into the unstructured data solution side as well. So like I said in the beginning, the storage needs are not one size fits all. You have various requirements. So all your needs will also have a project store that needs to be having enterprise features, data protection. You want have other features as well. That's where our Isilon family of PowerScale solutions come into play. So it supports you anywhere from edge to core, in bringing everything together for you. From a solution perspective, it provides you all the features you needed. So those who are familiar with this family of solutions, it's powered by OneFS file store. It can have all the enterprise features you're looking for, like data replication, data dedupe, scalability. You have various tiers in it, starting with NVMe all the way to the archive tiers. So it can scale pretty well. It provides you all the enterprise features. It provides you various options to connect to it. So you have a highly versatile solution that can be used for your enterprise class data store. This also sits very well with your validated designs for Pixstore or BGFS, because either you can have automated data move from your scratch file to the project store, or you can use tools to do that. So they coexist. That's the first slide I showed you, saying that, hey, we want to support all your use cases with various options. In the PowerScale family, we had two recent releases. There's a whole bunch of others as well, which I'm not showing here, but the two recent releases is one for the archive section. You have an A300 or A3000. You can read through the slides, all the details on it. It essentially gives you a very large capacity per rack. You also have a hybrid solution that gives you less cost, but much better performance. So you have lots of options, all the way from, like I said, all flash, all NVMe, fast tier, all the way to the a hybrid storage solution, all the way to the archive. And lastly, I want to touch upon object stores. Every one of you will be in the market for a cloud-based solution, and all the cloud-based solutions will be talking about S3 as the primary one. So we want to talk to you about your own cloud solution with ECS. So this provides you everything that you need in your own data center, so you don't have to worry about your ingress and egress costs. It gives you a very clean integrated connectivity to the PowerScale that I just showed you. We can have connectivity to the scratch file system for Pixel or BGFS. So it also fits into your scheme of things. You can put your data into it either as an archive or as a data lake, or as for something that you want to use once in a while instead of sending everything to the tape. So it gives you a lot of options, folks. So again, that's what I want to show in my 10 minutes time I have in this session. Essentially, I want to summarize by saying that we want to solve your various use cases by providing you different solutions for it. It's not one size fits all. Every use case will have a lot of data. It requires a well-optimized architecture that makes your deployment simple and easy and reliable. So that's what we intend to provide here. So that's a quick overview of our storage solutions that I'll be looking into. I'll hang around if you have any questions. Otherwise, you can always reach out to me or any of your sales associates to help you through the data needs.
I have questions.
Hey.
Wait, go back.
Go back. All right. Which one?
This one.
All right.
So tell me more about ECS. I have heard that it's more of like long-term data storage or archive. Is that right?
That's correct. It's a long-term storage. It gives you various kind of connectivities. It's for the object store, and it's your own private cloud, if you may.
So how is that different from, say, a storage server? Is it the same? Is it different? I mean, for example, I'm thinking of like the XE70, I think it's 7100, has 100 hard drives in it. I'm just trying to figure out, when would I need a storage server with 100 hard drives versus ECS?
One simple way to put it is do it yourself versus everything built for you. So as you can see, there's a lot of software that goes around ECS that you can see in this picture around. It gives you various connectivity. So if you're trying to build your own using an XE7100 100 drives, awesome solution. It gives you an object store. A lot of people use that for a different kind of data stores, and it depends on what you want to do. This is a full-fledged appliance that gives its own life cycle, well supported with this software ecosystem, and it fits well with all your other solutions. So XE7100, since you mentioned upon, is a great solution for Ceph if anybody's trying to use that.
Yeah, I think that I'm just trying to get a better understanding, because it seems like there's I would call it a convergence of servers and storage, because where in storage platforms in the past, there used to be, I would call them, or they were called storage controllers, and they were really lower bin processors. But now that's changed. In other words, it seems as though for storage, they're putting higher and higher bin processors inside the storage. So then it frankly smells more like a server. So I'm just trying to also get a handle on, do you see that as a trend, or is there still a pretty hard line between, you know, even though there are hard drives and servers and hard drives and storage? Tell me more about how do you see it?
So you can always have a software stack that needs to run somewhere. That's where the servers comes into play. I'm going to simplify it as simple as possible. And then you have some place to store the data. You can, it's all converged in the same unit, or you can have a connectivity to an external storage that all works in tandem. That's a way to do that. So it really, again, depends on the end user's requirement, whether you're looking for a smaller footprint, whether you're looking for speeds and feeds, whether you're looking for scale, whether you're looking for a particular type of use case. So going back to our fundamental thing is there are so many different ways our HPC customers use data, and every one of them will have its own unique nature, and one, if not more, of these systems will support that. And let me make sure that it's also going back to whether you want to build it yourself and do it yourself and looking for a la carte support, or you want to have a full-fledged experience of a fully support solution.
I'm not sure I know what you mean by fully supported solution. So do you mean that other items are not supported?
Everything is fully supported. If you're trying to buy a server with XE7100 and you're deploying a Ceph, for example, as your own, then you're doing it yourself. Whereas a well-defined, validated design versus an Isilon or a PowerScale has its own ecosystem of support and engineers that's optimizing in a continuous fashion.
Gotcha. And then you had said that this connects to cloud. So I'm looking at the picture and I see S3 and some Swift and other items. Can you tell me a little bit more about how that works?
So I'm not an ECS expert to begin with. I can get an ECS expert to come and talk to you about how it connects to the various clouds. And there are other cloud solutions that ECS and Isilon supports as well. You can have an S3 protocol connecting to your public cloud or your colos or other locations as well. So data may or may not stay in a customer data center. It can also be in a public cloud. It can be integrated through those protocols.
Awesome. Thank you, as I'm just trying to learn more.
No problem. Thank you for the questions. All right. Any other questions?
I think you already covered Pixstore and BGFS. Did you have any tips for me on, for example, how do I pick a file system?
Well, there are two ways to do that. So one is your use case, right? At the end of the day, the fundamental use case in a file system is whether you're looking for a parallel write and read. What's your requirement? Are you simultaneously reading and writing to the same block, or are you trying to have a very large file size? You're looking for ultra low latency. Say you're looking for something that is a pure scratch where the data need not be protected. So various variables come into play, and you can pick and choose based on that. Traditionally, a parallel file system is a 2 or 3 major options are out there. They are there for a long time. There are also newer solutions out there as well. So based on these variables, you can come into one of your decisions. In our case, BGFS as an example, is pretty simple to deploy and manage. So it provides you an ease of how you deploy and manage a highly complex parallel file system space. Pixstore provides you various options to build it and connect with other POSIX file systems. So tiering and scaling, it all comes into play. So the best would be to come talk to us with your requirements, and we can provide you the right guidance around that.
Perfect. Thank you.
Cool. All right. Thank you very much.
Thank
Great
you.
session.